welcome back once again. Uh, Here we were, and we have used the techniques to calculate horizontal and vertical component of the force. Then we have resolved for calculating the angle, the direction of the force, and then we reached up to a point where you were given the horizontal and vertical component of the force, and then you have calculated their magnitude and direction of that force. Now, this is another problem which the steering of a car has a radius of 16 centimeter. Find the torque produced on a couple, that is 15 Newton. But the couple is we have already done two equal and opposite forces which produces rotation in the body, that is called couple. So this is basically the radius 16 centimeter. So in meter it will be 0.16, and the couple force is 15 Newton. So you are asked to calculate the torque. This one. Find the torque. This one. So look at what you need. You need to calculate formula of torque is tau, that is equal to R multiply F, force into this displacement. So here it is. So here force is acting this one, and this is basically radius. But you know, when you are holding any type of steering, basically the distance between the steering is from this point to this point. If you are applying one force in this direction, you are applying the other force to this direction. This is the point of rotation. And what is the distance between the two? If this is the radius, that is 16, then of course it is the same to the other side. So that's why you're taking the double of these two. So this is the moment arm double, that is 0.616. You have make it twice, so it becomes 16 Newton meter. This is the most important to understand. In some other cases, you will directly use the moment arm, but in this case, you have to understand the situation. Situation is that you are holding this steering from this point, this one, and from this one. So it means what is the distance between the two? That is basically twice of the radius. Here the radius is 16, then the total distance between the two forces will be 32. So you have multiplied it with 2 so to get it twice. So this is the answer to calculate the torque. So torque is equal to 16 Newton meter. So next one is a picture frame is hanging by two vertical strings. The tension in the string is 3.8 and 4.4 Newton. Find the way of the picture frame. So you know you have to apply a condition of equilibrium. Whatsoever, if this one is this one, both vertical forces are acting. You know the direction of tension is always in upward direction. If you draw the figure to the other side, it is acting in downward direction. So you are asked to calculate tension in the spring is this one. Find the way of the spring of the picture frame. So here the picture is hanging. One side it is 3.1 and to the other side it is 4.4. There will be total of these two. The weight is acting in downward direction. Tensions are acting in upward direction. At the end, what is the end product? We apply first condition of equilibrium. Sum of forces, because it's not moving to the right or the left direction. So that's why we are not considering the horizontal component, component X component. The only components are the vertical component. Tensions are acting in upward direction, weight is acting in downward direction. The frame is at rest, it's not moving up or down. When it is at rest, then we have to see what type of forces are balancing each other. So these are the two forces are the F1y and F2y, that is T1 or T2, and the weight is acting in downward direction. The direction of weight is opposite to the direction of tension, so that's why you are taking minus sign, and it is at rest, so that's why sum is 0. So if you simplify it, that weight is equal to, of course, whatsoever, at that case when it is balanced, it clearly shows that whatsoever the amount of tension is acting in upward direction, the same amount of weight will be acting in downward direction. So after putting the values, we are getting weight is equal to 8.2 Newton. So this is your answer. The same amount of the tension adding these two is acting in upper direction. So that's why it is in the state of rest. So this was the concept of hanging frame, and this is a concept when the tension and weight are acting on a body, and both are in vertical condition. If you are asked to calculate one of them, then it will be easier for you. And you have to see the body is at rest or it's moving. If it is rest, then both are balancing each other. Upward and downward forces are balancing each other. So you have to apply the condition that is in which direction both the forces are acting, vertical direction. So sum of all the forces acting along vertical direction is zero, and you have to see how many forces are two here when weight with both are acting in upward direction. They are collectively applying force. They are all together applying force in upward direction. What about the other one? It is weight is in opposite direction. So here it is. Turning vertical force is another problem that is two blocks away, 5 Newton and 3 Newton. This one is 5 Newton and this one is 3 Newton. M1 is 5 and M2 is say 3. Then what is are suspended by two strings as shown. Find the tension in each string. So you are asked to calculate tension in each string. Tension is also always acting opposite to the weight. So if the weight is acting in downward direction like this one, then at the same time tensions are acting in upward direction. Tension in the lower string is basically this one, that is T is equal to mg. This one is mass multiplied by the g, that is 30 Newton. Similar is the case for the upper one. Of course, during the upper one, the both weights are acting along this direction. That is, if you look at here is only 3 kgs, but if you look up, here is the point where you are going to calculate if this one is T2, the down one is T1, this one is T1. And if you look at, if you are here, you are holding anything and some weight is hanging with your foot. First of all, you have to see what weight is acting on your foot and then what the weight is acting on your whole body. So this is the most important to understand. This is the tension acting up to this point at this point, 3 kg, and you have to calculate that tension. But if you look at this one, it is tension due to 5 kg as well 3 kg, and then you will add the two, and then you will multiply with its uh, value of G. So you will be getting tension here 80 Newton, because when you add these two, weight is more, tension will be more. So this is the technique to apply to calculate in case of a weight is acting in downward direction. If you are asked to calculate separately the tension in the string. So with this, our class ends today.